Today we're going to talk about explicit and implicit equations. Here's an example of an explicit equation. Y equals 2x squared minus 3. Or y is equal to the square root of 9 minus x squared. Or y is equal to sine inverse of pi x. These are explicit equations because they are explicitly solved for y. They all say y equals. Implicit equations would be like this. X squared y is equal to x plus y. That's a situation where y is not solved for. X squared plus y squared equals 9. Another example of an equation that is not solved for y. Sine of xy equals x minus y squared. Again, an equation that is not solved for y. This is where derivative notation comes in handy. We know how to find these derivatives. Well, I guess not the last one. We haven't talked about inverse trig functions yet and their derivatives. No big deal. We can learn it later. But implicit equations, that's a different story. How do we take derivatives like that? And that's what we're going to look at today. F prime of x means derivative of f with respect to x. So it's identifying x as the variable. And it's naming f as the function. And again, in that situation, it's explicitly solved for as we had in the first three examples. But if we have d over dx, that's different. It does mean derivative. But it doesn't identify the function. It just simply means the derivative with respect to x. This does name the variable that you're trying to find the derivative of. So derivative of y with respect to x. This is a fancy way of saying y prime. It's assumed in mathematics that if you're using the variable y, then x is the dependent variable. That's how we operate. So I need to show you something that you've been doing that you didn't realize you were doing, okay? So if I give this example, say I give you y is equal to 4x minus 5. What is y prime? What's the derivative? 4. Now, if I change that slightly and I say I have 5y is equal to 20x minus 25, are those the same equations? Yeah, and so the derivative should be the same. So instead of having so this is implicit because y isn't solved for yet. And you say, well, just divide by 5. Well, hold on, okay? If I asked you what the derivative of 5y was, what would you tell me? You'd tell me 5, right? Now, let's think about that a little bit because when I asked you for the derivative of y, you didn't tell me it was 1. You told me it was 1y prime, right? The derivative of y is 1. But when you're taking with respect to x, it's 1y prime. The derivative of 5y is 5, but y prime equals, what's the derivative of 20x minus 25? 20. And then when you divide by 5, sure enough, you get y prime is equal to 4, which is exactly what we had before. So the idea is every time you took a derivative of this side, you actually attached a y prime. And so you're going to see why that happens. It says, find the derivative of the circle x squared plus y squared is equal to 36 using implicit differentiation. So if we take the derivative with respect to x of x squared plus y squared is equal to 36, I'm going to take the derivative of each part. So d over dx, the derivative of x squared, plus d over dx y squared equals d over dx 36. Now, here's kind of how and why they use this notation in calculus. It's kind of interesting. I choose to use the f prime most of the time because you guys seem to understand it best. But what is the derivative of x squared? 2x. And so notice that what happened was the power got reduced by 1, right? Every time we take a derivative, the power is reduced by 1, right? So it's kind of like one of the x's went somewhere. And so they attach it right with that d in the numerator. It's like dx over dx times 2x. Plus, what's the derivative of y squared? 2y. And again, the power of y was reduced by 1, so they'll put that 1 up there. And then what's the derivative of 36? 0. And 0 times d over dx will give you 0, okay? So what is dx over dx? 1. So you end up with 2x plus, and what did we say is the same thing as dy over dx? Just y prime, right? And so our goal is to solve for y prime. How would we solve for y prime? Yep. And divide by 2y. Y prime is negative x over y. And so now the derivative doesn't just depend on one variable, but rather on two. And so what I'm going to do here is we're not going to write these summary things, but I'm actually going to make a sketch of the graph. You guys are going to see what the heck it is that we're talking about here. What shape does this make right here? Circle with a radius of 6. Sweet. Yeah. Practice makes perfect. Okay, so look at this. It says y prime is equal to negative x over y. Let's understand that in the context of this graph. Let's look at the slope of the line tangent right there. What's the slope of that tangent line? 0. So if I were to plug in 0, 6, y prime is equal to 0 for x, 6 for y, I get 0. What is the slope of that red tangent line? It's undefined. So y prime is equal to, if you plug in a 6 at that spot, so negative 6 over 0, you get undefined. So you can see that if you want to find the slope, it now requires that you just plug in both the x value and the y value. Go get some brain food and come on back. We'll try some examples. Here we go. Use implicit differentiation to find the derivatives of the following equations. Here's the idea. What's new about today is whenever you take the derivative of y, you attach a y prime. So the derivative of 3x squared. The derivative of 4y, it's going to be 4, but you attach a y prime. If you're wondering why we attach y prime, you got to go back to the previous page to see about that dy dx thing. Remember, the dx over dx just went away. But here we had a dy over dx, which is the same thing as a y prime. Equals derivative 4x. 4. Solve. Negative 4y prime is equal to 4 minus 6x divided by negative 4. Y prime is 3x minus 2 all over 2. What do you think? Let's try again. Where? Oh my gosh. Okay, sorry for the pause there. They noticed I had some type of crud on my shirt. Not very well dressed today, so. Insert a picture, yeah. Oh, wow. Now I'm embarrassed. I'm going to put on a jacket. Okay, here we go. Okay, next one. Derivative of y to the third. 3y squared, and you have to attach a y prime. Every time you take the derivative of y, you attach y prime. Minus 5 plus 2y prime equals 3. What's different about this one? Yeah, you have multiple y primes. So what you do is, you remember this last year in your college algebra course, you had a great teacher, he taught you how to do this. 3y squared, y prime, plus 2y prime is equal to 8. You gather all your y primes on one side, and then what do? Factor out a y prime. You'll have to 3y squared plus 2 is equal to 8. Y prime is 8 over 3y squared plus 2. That's it. Why don't you try C on your own? Go. Okay, so I have 9x squared minus 1 over 4y minus 16y cubed. Is that what you got? Just to note, if you put your y primes on the other side, you can come up with 1 minus 9x squared over 16y cubed minus 4y. And that's the same thing, y. A negative 1 on the top and bottom, so. Yep. All right, let's do our last one. Actually, not our last one, just last one for this section. We'll do the n, 10y prime, 9. But what about that 3xy? Oh, no. Anybody got a great idea? I'm thinking of something we've already learned. Product rule, awesome. That's, I'm going to call f the 3x. I'm going to call g y. So f prime will be 3 times g, which is y, plus g prime, y prime times f. So I have 3xy prime minus 10y y prime is equal to negative 3y minus 9. Factor out my y prime. And divide. I like your haircut. Shoot. Are you sure? Are you sure? All right. All right, like your hair. Okay. So all right, let's add one example. Let's do 2 sine of 3xy is equal to x plus y. What rule do you think I would have to use to take the derivative of the first part? Chain rule. Very good. And product. Kelsey's a little genius today. All right, genius. What's the outside? 2 sine of u. What's the inside? 3xy. You okay? Is that usual? Sorry, YouTube, we just heard a very odd sounding sneeze. Wow. Next time, raise your hand, I'll bring the mic over. Okay. That Tiger's roar, save it for that. Okay. All right. So derivative of 2 sine of u. And then how do I do the derivative of 3xy? Product rule. Derivative of 3x times y plus 3x times, what's the derivative of y? Y prime. So I multiply those together, and I get 2 cosine of 3xy times 3y plus 3xy prime equals, how about the other side? What's the derivative of the other side? 1 plus y prime. Okay. Not very pretty, is it? Just let's distribute and get rid of parentheses and then move stuff over. Okay. So it looks like we'll have looks like a 6 xy cosine. Whoa, what am I doing? 6y cosine of 3xy plus, now I'm going to distribute this here. So I just distribute it to the 3y first. Then I'll have right here, it's just this part. Okay, so 2 cosine times 3y gives me negative, or gives me 6 cosine. 6y cosine. Of the 3xy. This is not times, this is of. And I've got 6xy prime cosine of 3xy equals 1 plus y prime. Okay, so I got to get my y primes on the same side, right? So of 6xy prime cosine of 3xy minus y prime equals 1 minus 6y cosine of 3xy. Now I can factor and divide, right? Y prime times 6x cosine of 3xy minus 1 equals 1 minus 6y cosine of 3xy. So I get a nice answer here. Cool. What do you think of that? Should we try 2 easier problems? And then we'll call it a day. Flip your notes over. We go back to the basics. Write an equation for a line tangent. What 2 things do I need? Slope and a point on my line. Point on my line is -7, -24. How do I find the slope? Derivative. Derivative x squared. Derivative of y squared. 2y prime, derivative of 625. Zero. So y prime is equal to negative x over y. Cool. Nope. That's the derivative. So what is the slope? What do you have to plug in? The point. So x is negative 7, so it'll be positive 7 over negative 24. Or negative 7 over 24. Now I need to write my equation for my line tangent. So y equals negative 7 over 24x minus 49 over 24. And I'm going to subtract the 24 over. Find common denominators, 576 over 24. So y is equal to negative 7 over 24x minus 625 over 24. Cool. Yeah, isn't it kind of fun? You see the 7, the 24, and the 625 in the answer. That'd be a good problem to put on your final exam. Yes. And last problem. Point on line is 1, 1. Slope, take the derivative. 2x plus product rule. 4y plus 4xy prime. Nice job, Dylan. Product rule. Yeah, there you go. Throw stuff at him. Okay. Minus. Minus 4y prime. Equals 0. 4x y prime minus 4y y prime equals negative 2x minus 4y. Y prime times 4x minus 4y equals negative 2x minus 4y. Divide. And they're all divisible by 2. So y prime is equal to negative x minus 2y over 2x minus 2y. What do I plug in? For both of them, right? So on the top, I get 1 minus 2, or negative 1 minus 2, which is negative 3. On the bottom, I get 0. So I get negative 3 over 0, which is undefined. Whoa, no! I just answered this question on my way to lunch. I popped into another class where I said, any questions? Because the teacher was gone for the day. I said, any questions on math? They're like, yeah, how do we write an equation for a line with an undefined slope? And I said, oh, piece of cake upside down. What kind of line has an undefined slope? Vertical. Is that an x equals or a y equals? What is the x value that it goes through? 1. That's the equation of your line tangent. Awesome. Assignment. There you go. Me? That's because I get to teach you guys. I have gray hair. I really started to get gray a couple years ago. No, from the time I was 32 to 37, the amount of hair that I lost and the amount of gray hair I got, it just really, yeah. What? Still recording, I know. I'm waiting for you to... I'm waiting for you to sneeze again, Maddie. All right. Good luck. You'll need it.